Alright, so in this video I want to talk about how I went about using Carbide Create to drill holes into my wasteboard to put threaded inserts in. It's one of the first projects you'll probably want to do. It's a common means that people use to secure stock to the wasteboard. So they use the Shapeoko itself to mill all of these holes into the wasteboard, and then they put a set of threaded inserts into each of these holes, and then you can use a bolt along with a clamp to hold the stock in place while you're doing your normal milling operations. So it's one of the first things you're going to want to do just to get off the ground with the unit, unless you've got a different way to secure the stock. So before I tackled it, I read a bunch of different articles about it. The folks at Carbide 3D have this one, which was a great read. There are lots of helpful tips, but as they point out here, I mean, this can be done on different machines. I have the XL, for instance, but you'd have to make some tweaks to it. So I use this sort of as a guide along with another post that I'll show you in a second, but then I ended up just designing my own pattern for the holes. But I highly suggest that you read through all of the tutorials you can possibly find on the matter, just to look out or get an idea of things that other folks have run into, problems, and that kind of stuff. So this was a good read. They also suggested, which I had thought all along was a good idea, but lots of folks did it the opposite. They suggest that you drill the holes in. I think they talk about it down here. Yeah, so you drill the holes in, and then you flip the wasteboard over, and you put the inserts in from the back. And it's because the inserts are tapered, and you've got more holding power if you're pulling against them rather than just the holding threads if you put them in from the front. So that's one thing I took from here for doing it. But again, just a good read. Go out there and find as many articles as you can about how to do this, and then you can try to tackle it yourself. The other article I read was by Winston Moy. He talks about how he did it on an Excel table. You'll note here you can see that he did it the other way around. He put the inserts in from the top, and I think he said he did that because he thought it just looked cleaner. But he's also got some other tips on how he did it. There's also a video in here, I think. So all good reads. In the end, I came up with my own design, so I want to walk through how I did that using the Carbide Create software. So let's get right into that. So the first thing you're going to want to do, obviously, is open the Carbide Create software. And what I did is I took some measurements of my wasteboard of the actual cutting capacity of the machine to sort of come up with some numbers about how big of a grid system I wanted to make for my thread inserts. And the number I came up with was 30 inches on the x-axis and 13 inches on the y. And I came up with this based on, this is not the total cutting capacity, but it avoided some of the problems I wanted to stay away from, namely running into things like existing bolts that hold the wasteboard in, largely a plane it safe maneuver here by keeping it to this size. And my thought was that if I need more later on, I could always add them. But for now, this gives me plenty of clamping area, and so I thought it was a good place to start. So take some measurements, figure out how to avoid the bolts, how to avoid, if you are going to mill all the way through, how to avoid the metal braces for the front and the back. I ended up, when I did mine, because I did want to mill all the way through, I ended up taking the wasteboard out, flipping it over because I wanted to put the inserts in from the back, and when I did that I removed the back 3 metal braces that support the wasteboard just so I didn't have to worry about milling into those. But there's a variety of ways to tackle this. Figure out what works best for you. So stock thickness, that is a 3/4 inch piece of MDF, I believe. We're going to be coming from the top. I do like starting in the lower left. MDF is right. I have the XL, retract height 10 millimeters, that should be fine. One thing I want to call out here that's pretty slick is you can put the numbers in inches or in metric and then just flip between them. So if you want to draw in millimeters but you started in inches, you just come in here and change this. I think we'll end up doing that a couple times, but for now we'll leave it in inches. So we'll say okay, and now we have our piece of stock to cut from here. So the first thing we want to do is draw a hole. So these are the holes that the actual inserts will go into. So I'll just draw a circle, and this is actually where I do want to go back to millimeters here. So I'll say millimeters. They suggested that the hole that you drill for the inserts I bought, which I'll link in the post, be 9 millimeters. And I did some test runs on a scrap piece of wood and found that an 8 millimeter sized hole was actually better. So that's what I ended up using. So the radius for that would be 4 millimeters. And then what I want to do is I want to mill out a little insert to go around this so that the thread insert can fully seat into the MDF. So I want to unselect. I'm going to draw another circle. And I want this guy to be, that was 4, 8, let's call this 6. So now I want this to be perfectly around the center. So there's a couple ways to do this, and I want to talk about this. The snap to grid feature is incredibly helpful, but you'll see here, depending on where you grab the shape, you can't really get it lined up where you want. So the first thing I did was I selected both of them, and I went to the alignment tools and I said center or align both the centers. So doing that gives us what we want, that they're centered together now. But the other trick is it's really a matter of where you grab the shape by. So if we, let's move this to the corner or the edge. So notice that when you're going to select something, it gives you these different blue text pieces that pop up for quadrants, and there's one for the center as well. So I can, if I grab from here, that is the point at which I am snapping to the grid. You see how that's snapping on all those pieces? So if I want to center on the center, I have to then grab from the center, and then I will snap on that. So same thing with this one. So if I want to align the centers, I just find the center of this guy, and I align him. So now I'm aligned. So that took me a little bit to figure out, just that it depended on where you grabbed from. So that was pretty handy to realize. So for now, let's put that over here. The difficulty that I ran into is I wanted to have these holes equally aligned across the stock, and without actually, counting individual squares, I guess I could have done that. It was sort of hard to figure out how to do that alignment. So what I did is I came up with a system of just drawing these squares, and so here I want to go back to inches again, actually, because I want these to be 3 by 3 inches. And I just ended up using these to do my alignment, so I'll show you what I mean. So I'm going to take this guy, again, notice I can select it in different places, but so I want the end here, and I want it to snap into the corner. So then what I'm going to do is I'm just going to copy this. So if you have it selected, hit Command-C if you're on a Mac. And I'm going to just keep aligning these. And you do want to zoom in and make sure you're actually aligned. But so this will become sort of our grid to work with. And I'm just going to keep doing that. I'm going to keep copying and pasting these as I go across. It's a little bit tedious, but once, see, you got to zoom in to make sure you're actually on the same point. But once we get a whole row done here, we're just going to copy the row, so it'll go much quicker. It's too far. Keep doing that. Okay, and if you did this right, when you get your last one in, you should be fully aligned with the end of the stock you defined. Right? So now I should have all of these lined up, and they look like they're pretty good to me. So now I'm going to highlight all of them. You notice you don't have to actually highlight the whole circle to select something. You just have to touch part of it. So then I'm going to hit my Control-C again, and I'm going to grab that end, and I'm going to come up here, and I'm going to zoom in to make sure I get it where it needs to be. And then I'm just going to do it again. Okay, and so clearly since this is 13 inches tall, that's not divisible by 13, so I didn't end up with any holes along the top piece, but again, I'm okay with this. This is my first go. Just want the ability to clamp some stuff so I can do some cuts. So now I'm going to take these guys, select both of them. I can hold down the Command key on my Mac to do that. Grab it by the center and put it right in the corner. So we're going to take the same approach here. And once we get a whole row of these, we're going to do the same thing. We're just going to copy the entire row. So it's sort of a made up alignment system. But for the purposes of this, it works pretty well. I'm used to using tools like Visio for doing drawings, where I can select a series of shapes and then tell Visio to distribute them along an axis. It's too far. That functionality just isn't here in Carbide Create yet, but I feel like this is a pretty happy compromise. So here we go. So this is our entire row. So now this is a little bit painful because I don't want to select the squares, but I will, oops. Zooming in seems to be the key to selecting items like this. So I will. The frustrating part here too is if you accidentally click off or you screw up the selection here, you have to start over in some cases. But again, just take your time and be careful. So now I should have the whole row selected. Yep. Okay, so then I'm just going to do the same thing. I'm going to say Control-C, grab it by the center, plop it up there. Same thing here. And there you go. So now these are all my holes that I want to drill. To make it easier to select the tool path, what I am going to do then is delete all of these squares, my setup squares. And do that just by selecting. Actually, it'd probably be quicker to go like this, right? Not a Mac to delete that, that's just function and then the delete key. Okay, so now I've got all my circles. So the next thing we want to do is define the toolpath. So to define the toolpath, we'll just head over to that tab. And so we're going to have two different toolpaths here. And this is going to be a little bit tedious. I don't know if there's a better way to do this, but we want to drill the holes as one task, as one toolpath, and the inserts as another, because they have different settings. So it's tedious because I have to go through here and select all of these individually. You'll notice later in the video where I show my machine doing the cutting that it appears to be running a little inefficient in the fact that it's not milling the holes sequentially. It's sort of bouncing around. I think that's likely based on how I, oops, see I grabbed the wrong one there, how I selected the items as I built the toolpath. I'm not actually sure though, so that's something that's on my list to play around with a little bit more. But it makes good sense because you could probably, I probably selected them in an inefficient order. I mean, the way I'm doing it right now isn't super efficient either, but I just want to show you how to define the toolpath. So almost there. The other thing I mentioned earlier, but if you want to mill all the way through, which I did, you want to make sure that you're not milling into anything. So I took the 3 metal support plates out when I took my wasteboard out to flip it over, and then I made sure that my starting point was far enough off of the front metal brace that I wasn't possibly going to hit anything. Okay, so now I should have all of the center holes checked, because if you define the toolpath wrong, okay, so that's good. So I'm going to say I want a contour toolpath. I want to go all the way through. So I'm going to say my stock bottom 3/4 of an inch. I want to do a pocket operation, and I'm going to call this through holes. 1/4 inch end mill, that's right. And I'm actually going to change this because when I ran this, this didn't actually poke all the way through. It's probably because the MDF is not perfect. So I'm going to change this to just 0.77 just to give us a little more depth. But again, validate that you can do this before you drill all the way through. So now we can look at a simulation, and there are all of our holes. So the next part here is to do the inserts, and again, a little bit tedious, but oops, let's click off, and we're going to select the outer ring. And we'll just keep selecting these guys. Oops. So some of the other tutorials I read, they did end up using different software than what came with the machine. I'm rather new to all this, so I'm kind of trying to stick with the basics for now, and the Carbide Create software to me seems more than efficient for what I want to do. But I'm sure at some point I will look at other pieces of software. But for now, I mean, this is some of this. I'm not sure if this would be more efficient in a different tool, but for now, this is a little bit tedious, but I think it works just fine. The other thing I'll point out is that I mentioned I'm putting the inserts in from the back, so I did have to flip my wasteboard around. I think one of the other tutorials, they didn't flip it around. They milled the holes and then flipped it. I didn't want to do that because my wasteboard in the XL has sort of recesses for the screws that are milled into the top, and so I wanted to obviously keep using those. So I flipped it and then milled my holes and then put the inserts in and then flipped it and put it back in the machine. So you want to just make sure that you're milling into the right side if there's something on a particular side that you want to keep using, like those recesses. Okay, we're almost got them all, I think. Perfect. All right, we'll just zoom out here. Great. So that's all the outer ones. So now we're going to make another toolpath, contour. In this one, here, I'm going to go back to actually, oops, not what I wanted to do. I wanted to click gear, and I want to go back to millimeters because I want those to be just a 1 millimeter deep. So we'll go to that toolpath here, which is showing up as 4, and we'll say we want that to be a 1 millimeter deep hole. Pocket operation, same bit. We'll call this inserts. Okay. So now if we look at our simulation, with any luck, you'll see that that's what we have. We have these little inserts and all of the through holes. So the next step would be to save this off as the G-code, load it up into Carbide Motion, and do all the normal steps. So make sure you set your 0 in the right place on all the axis and start milling. So I'll show you a quick video of what that looked like for me here. So I zeroed out the machine in Carbide Motion, loaded the G-code, and let it run. Here you can see it's doing the insert toolpath. It's being a little inefficient, as you can see, and I think that's just a means of how I selected the items when I ran this job, but I'll have to play with that some more. These turned out really well. nice clean holes. The holes themselves turned out not to be quite deep enough, so I ended up running the job again with the insert toolpath disabled, and I just made the whole toolpath a little deeper. So when this is done, I went ahead and put the inserts in. I thought at first I'd use some wood glue when I put them in, but it turned out that that wasn't really needed and it was kind of making a mess. So I stopped doing that, put all the inserts in, unscrewed the wasteboard from the machine, and then took it out, flipped it over, put the metal back braces, the 3 braces, back in, and then put all the bolts holding it together back in place. And in the end, I ended up with this. So my next step here is to cut out some clamps and figure out how to do the actual work holding using these inserts. So I hope this was helpful for folks who are trying to do this themselves, and thanks for watching.